Welcome! In the last lecture, we successfully created this blue flame and these flying embers. If you want your blue flame to be longer, you can do that by increasing its speed in the add velocity module. I'm not going to touch that, but I'm going to change some of the values for my embers. Right now, I don't think it matches with the movement of this flame. So go back to my Niagara system, go to my embers emitter. First, I'm going to decrease its spawn rate to somewhere between 10 and 20. Then I'm going to increase its lifetime, so its maximum lifetime, I'm going to increase it to 3.5 seconds. And inside of this add velocity module, I'm going to increase and 20. First, I'm going to go back to my Niagara system, go to my embers emitter. First, I'm going to decrease its spawn rate to somewhere between 10 and 20. Then I'm going to increase its life spawn rate to somewhere between 10 and 20. Then I'm going to increase its lifetime, so its maximum lifetime, I'm going to increase it to 3.5 seconds. And inside of this add velocity module, I'm going to increase this velocity speed to 300 and 450. And go back to my level. Yeah, something like this. I think this looks much better. And the last thing that I want to add is I want to create some heat distortion for this flamethrower. By adding this heat distortion to our flamethrower, I think it could really increase some interesting details. To achieve this, we need two things. First, we need a Niagara emitter. We can just use a sprite renderer for us to do this. And that's the only thing that we need from Niagara. The heavy lifting thing for this effect needs to be done through Meteor. And more specifically, there are three things that we need to do inside of our material editor. So first, we need to have a translucent object. Then we need to adjust this refraction rate. So refraction is just the bending of light, and this will happen when the light enters from one transparent substance to another. And Unreal has made this really easy for us to do. And in order to simulate this effect, one last thing we need is normal map. And this same technique could be applied to a water material. So let's look at how we can do this from material. Go back to my editor. I'm going to go to my material folder. I'm going to create a new material. I'm going to call this M_heat distortion master and underscore trans. So later, if other VFX needs this, we can just create material instance from this material. Double click to open it. I'm going to set its blend mode from opaque to translucent. Now we'll have a translucent object. Then I'm going to change its shading model from default lit to unlit. So first, I'm going to hold down 1 on my keyboard, and I'm going to plug a zero into the opacity socket. Okay, now we'll get a totally transparent object. And next thing, I'm going to plug a value into this refraction socket. Hold down 1 again and bring out this float. I'm going to change its value to be 1.33. So this is the refraction rate for water, and plug this into the refraction socket. Now we can already see something. There's already some kind of light bending happening for this plane. Alright, we're getting somewhere. And the last thing we need is some normal map for this normal socket. And we can find that inside of the pack we imported. So go back to my content browser. I'm going to go to the textures folder, this realistic VFX texture, and scroll down. You can find there's this T noise normal B, and there's this T noise normal A. Let's see what they will do to this effect. So I'm going to bring both of them in. And go back to my material edit them in. Let's see what's T noise texture. And I'm going to go to the textures folder, this realistic VFX texture, and scroll down. You can find there's this T noise normal B, and there's this T noise normal A. Let's see what they will do to this effect. So I'm going to bring both of them in. And go back to my material editor. So I'm going to try this one first. Plug this into the normal socket. You can see this is the heat distortion that I'm talking about. And this one, it has much more details if I plug this into the normal socket. You can see we get a much stronger distortion. So I think for our purposes here, this one here is enough. So I'm going to delete this texture sample node and plug this into the normal socket. Alright, we are getting somewhere. In order for this effect to look better, apparently we need to somehow move this heat distortion. And there's one node can help us easily achieve that. So the node is called panner. Basically, what this node does is it scrolls our texture, and we can specify which axis do we want to scroll it in here. So for example, now I give it a value of 0.1 inside of the y-axis and plug this into the UV socket. Now you can see it's slowly scrolling our texture, and by tweaking the value here, this can help us to achieve what we want. But with this kind of setup, we have one issue. Let me just quickly show you. So I'm gonna click apply in here. And go back to my content browser. I'm gonna create a material instance from this master material. So I'm going to name this mi underscore flame heat distortion underscore trends and move this material instance to my flamethrower folder. So you'll be inside of this UV animation. All right, and double click to open my Niagara system. So I'm going to quickly add in another emitter. All right, and to my flamethrower folder. So you'll be inside of this UV animation. All right, and double click to open my Niagara system. So I'm going to quickly add in another emitter. So right mouse button click and add this simple sprite burst. In order for us to see this emitter better, I'm going to isolate it first. And I'm going to swap out its material. So selecting this heat distortion and click this icon. icon. Now you can see we have a very small plane in the middle, so I'm going to increase the size of it. I'm going to try 200 for now. Middle, and click this icon. Now you can see we have a very small plane in the middle. So I'm going to increase the size of it. I'm going to try very small this heat distortion and click this icon. Now you can see we have a very small plane in the middle, so I'm going to increase the size of it. I'm going to try 200 for now. So that we can see it. And I'm going to change this emitter state, this loop behavior, from 1 to infinite. Alright, go back to our level. You can see this is what we get. But apparently there are more things that we need to do. So first we need to hide this seam for this heat distortion. At this moment it's too obvious that this is a texture. So whenever you want to hide something inside of your texture, oftentimes you'll need the mask. So I'm going to go back to my master material. So right now, this refraction is entirely depending on this normal map. For the areas that have the normal map, we can get this heat distortion. And all we need to do is, we need to remove this effect for the seam of this plane, which means we shouldn't have normal map in these areas. In order to have a 0 for the normal socket, we can't just plug in a value of 0. Let's just have the seam of this plane, which means we shouldn't have normal map in these areas. In order to have a 0 for the normal socket, we can't just plug in a value of 0. That's just not how normal map works. Instead, we need to use a vector 3. So I'm going to hold down 3 on my keyboard to bring it out. And I'm going to give it a default value. So I'm going to hold down 3 on my keyboard to bring it out. And I'm going to give it a default value of 1 in the z-axis. So the strength of the normal map depends on the value of x and y. So the stronger the values for the x and y, the stronger the normal strength will be. And having a 0 in the x and y, we'll get no normal strength. And now all we need to do is we need to combine these two nodes together. And we can easily do that by using a lerp node. So I'm going to plug this 0 normal strength into socket A and plug this normal strength into socket B. Now all we need to do is we need to find a value to plug into this alpha socket. And that can easily be our mask. So when the value inside of the alpha socket is 0, value A will go to the final output. When it's 1, value B will go to the final output. And we have the perfect mask just for that. So go back to my content browser output, and we have the perfect mask just for that. So go back to my content browser. If you go inside of this file VFX textures, go inside of this file single, you can see there's this big file underscore single. And this is the exact mask that we need. So I'm going to isolate its channels. First, I'm going to only show the red channel. So this is the mask that we can use in the red channel. And this is in green channel. This is in blue channel. This is its alpha. So I think I'm going to use the red channel. or you can use the green or blue channel since they all have the same values. And remember, this is just a value ranging between 0 and 1. Alright, go back to my master material. I'm going to bring in this mask. And I'm going to plug the red pin into the alpha socket. And plug this into the normal socket. Now you can see that seam is gone. And if you want to adjust your mask a little bit, you can easily do that by using a power node. So I'm going to use the power node in here. And I'm going to preview this node. So this is currently its value. Now the value is 2. Right after I change it, say maybe 5. This is what we get. So I think a value of 1.2 would be enough. Alright, something like that. So the power node can be used to adjust the contrast of a mask. I'm going to start previewing it. And now I'm going to create some parameters for this material so that we can adjust it in the material instance. So there are 4 values that I like to control. I like to control its speed x, speed y. I want to control the contrast of this mask, and I want to control this refraction rate. So we need 4 scalar parameters, or we can use a vector 4 parameter. So we can hold down V on our keyboard and left mouse button click to bring it out. So I'm going to change this to distortion settings. So this is the same as bringing out 4 scalar parameters. And we can change each channel's name in here. So I'm going to click this drop down inside of the channel names. For the red channel, I'm going to name it to be speed X. For the green channel, it will be speed Y. For the blue channel, it will be mask contrast. And for the alpha channel, I'm going to call it refraction rate. I'm going to give it for the alpha channel, I'm going to call it refraction rate. I'm going to give it a value of 1 for the speed Y. For the mask contrast, I'm going to give it a default value of 1.3. For the refraction rate, I'm going to try 1.2. Now all we need to do is plug this values in. So first will be the speed X and speed Y. We can combine these 2 single flows together and plug them in into this SB socket. And we can use a no make flow 2 to do that. And plug this into Y socket, plug the result into the SB socket. Alright, for the mask contrast, I'm going to plug it into this power node. And I'm going to adjust this pin a little bit, drag it down to organize my graph a little bit. And now last thing will be this refraction. So I'm going to plug this into the refraction socket and delete this node and drag this node down. Alright, just like that. Now we have our heat distortion ready. I'm going to hit apply and go back to my level. Like that. Now we have our heat distortion ready. I'm going to hit apply and go back to my level. Now you can see we have a much nicer heat distortion. All we need to do now is to adjust some of its properties and maybe the size of the plane so that it aligns with our flamethrower. So go back to my Niagara system. I'm going to first disable emitter isolation and I'm going to hit play. Now it's very hard to see that, so I'm going to go back to my level. Now you can see it's at the origin of our flamethrower, and I want to lift it up and I want to move it to the tip of this flame. So go back to my Niagara system. I'm going to isolate it. First, I'm going to set its position offset. So click this initialize particle. For this position offset, I'm going to set it to be 300 units. And in order for us to see better, I'm going to increase its sprite size to 500 units. And go back to my level. So right now, it's at the end of the flame. Let's see what it looks like. Alright, this looks good enough. Now I'm going to lift it up a little bit. So inside of this position offset, I'm going to lift it up 200 units. Alright, something like this. Right now I think this is too much. But this does look good. You can see we have the exact effect that we want. So I'm going to decrease the size of this plane a little bit. So go back to my Niagara system. Instead of uniform, I'm going to set it to be non-uniform. So I want to set the size of its x and y separately. So for the x-axis, I think a value of 200 units should be enough. For the y-axis, 300 units should be enough. And you can see now the position of it is not correct. And that's because the pivot point of this plane, because we changed the size of it, and now the offset values for it is too much. So by default, the pivot point of this sprite will be at the middle, and I like to offset it to the bottom of this plane so that we can scale this plane in the y-axis. And we can do that by going back to our Niagara system inside of our sprite renderer. We can adjust this default pivot point in UV space. If your mouse hovers over it, you can see that if the value is 0, 0, the pivot will be at the upper left, and if it's both 1 and 1, it will be bottom right. The middle is 0.5 and 0.5. So I like to keep the value for the x-axis, but I'm going to change the value for y-axis to be 1. So now the pivot will be at its bottom. And I'm also going to set the sprite size to be 1. So now the pivot will be at its bottom. And I'm also going to set the sprite size to be a user parameter so that we can adjust it faster. I'm going to type user parameter in here, and I'm going to change the name. So I'm going to right mouse button click and click rename. I'm going to change it to heat distortion size and go back to my level. Now you can see that plane is way up. So I'm also going to change this position offset. I'm going to say back to 0. So I'm also going to change this position offset. I'm going to going to say back to 0. And I'm going to adjust its size in the level. So click this Niagara system. I'm going to try 150 for now, or maybe 200. And for the x-axis, I'm going to change it to maybe 300, 350 for the y-axis, maybe 250 for the y-axis. Alright, something like that. And I'm going to try to look at it from different angles. Alright, this already looks good enough. And if we are not happy with how fast this texture moves, we can adjust it inside of this material instance. And thanks to this parameter we just created, so we can change its speed white. So if you think it moves too slow, you can change it to maybe 1.5. Now you can see it moves much faster. I think 1 is enough. And the mask contrast, if you change it to 2, we'll get less heat distortion. But right now, nothing is changing for my the reason why nothing is changing is because I forgot to plug this pin back in. So I'm going to plug this into the alpha socket and click apply. Now I'll go back to my level. You can see we get less heat distortion. So I think I'm going to change it back to 1.2. And the refraction rate, if you try to take this value, say 1.5 now, you see we get much more distortion. reflection, and if you decrease it to 1, we get less heat distortion. So I think 1.2 is enough. Alright, something like that. Yeah, I think I'm quite happy with what I have in here. Later, when you try to implement this by yourself, these are the nodes that I use inside of my material graph, so you can take a reference of it. And same as usual, if there are nodes that you still don't understand, feel free to post a question about it. And for the Niagara part, you can set the pivot point of the plane inside of the sprite renderer. In that way, you can scale the plane more easily. Feel free to refer back to the video if you need help. Now, time to create your own heat distortion. I'll see you in the next lecture. Welcome back. Now let's do a little recap on the VFX that we just created together. Looking back at these 3 questions, I'm sure at this point you already know the answers to them. So for this VFX, we've only used the sprite renderers. And for the elements, do you still remember what textures we have used? Well, we've only used some flickable textures for fire and smoke, and some normal map for this heat distortion. For the forces and material, those are the key things to help us to pull this VFX off. And I hope you still remember what the modules we use. You don't need to remember all of them, just a few that we use all the time. The reason why we're doing this is, instead of knowing how to create one VFX, in the future you can apply all of these skills and knowledge to the VFX that you want to create by yourself. And eventually, you're going to get to a point where by looking at something, you can say, oh, that's curl noise force, that's a velocity from cone, oh, that's a material effect. and those are the nodes that I need. You're not gonna get there right now, but as we create more and more VFX, as you see more and more examples, it's gonna happen. And all the things that we'll be doing inside of this course will help you to get closer and closer to that spot. So feel free to write down anything that you think are important on the demo display, and those will be the things that you can revisit in the future. And usually, they are the most valuable things. Alright, however, back to my project, there's one more thing I'd like to do. Say now we really like this VFX, and for our Niagara system, say we really want to create a thumbnail for it. We can easily do that by opening our Niagara system and click this thumbnail button, and this will capture the viewport as its thumbnail. So you can see, now we have a custom thumbnail for our Niagara system. And I think I don't really like this background. We can get rid of that by going back to the Niagara system. I'm going to adjust my viewport a little bit so I can capture this VFX a little bit better. Alright, something like that. And you can go to your preview scene settings. And inside of it, you can see there's this environment drop-down. Click it, and you can untick this show environment. And we can change this environment color to completely black, something like that. Yeah, I think this looks much better. And click this button again. And go back to our level, you can see, now we have a much better thumbnail. If for some reason you don't have this tab, you can enable it by going to this window and tick this preview scene settings. Alright, now I'm gonna enable my environment back. And that's pretty much it. After creating this effects, now if we go back into our textures folder and open this realistic VFX textures. So for all the flipbook textures, if you know how to use one, you know how to use every one of them. So there are a bunch of variations that you can create by the same techniques. So if you'd like to create your own explosion, you can do that. You like to create different types of fires, you can do that. And there are a lot of other fire textures inside of this folder. Say you like a torch, these are the textures that you can use. Or you want some candle fire, these are the textures that you can use. And all the things you've learned so far can be applied to all of these textures that you just saw. Alright, starting from next lecture, we'll look at what other renderers could do. And this is only the beginning. We're going to create a lot more amazing VFX. When you're ready, I'll see you in the next lecture. Welcome. In this lecture, we'll look at how we can use the mesh renderer inside of Niagara system. So first, I'm going to go back to my Niagara folder, and I'm going to create another folder. So I'm going to call it 08 mesh renderer, and inside of it, I'm going to create a Niagara system directly, and choose new system from selected emitters, and select this simple sprite burst, and click finish. So for this one, I'm going to call it ns_mesh renderer, and double click to open it. So to change an emitter's renderer, we can go down to this sprite renderer, and we can directly delete this renderer, and we can select the other renderers we want in here. So I'm going to select mesh renderer and go back to the selection tab. So you can see under this mesh rendering section, there's this drop down says meshes. And inside of here, we can specify the mesh that we want. So inside of here, I'm going to type cube, and you can see these are the default cubes from Unreal. I'm going to select this sm_cube02. If you're not seeing this, make sure you have this show engine content enabled. So after that, you can see in my viewport, I'm spawning a particle, and that particle is this cube that I just specified. And this is everything. Because if this is a particle, that means we can apply different forces modules to it. We can scale its color, we can scale its size, we can change its rotation. Everything that we've done to sprite renderers can be done inside of mesh renderer. Everything we've learned can be applied in this renderer. And that leads us on to our challenge today. So your challenge is, I'd like you to use mesh renderer in render stage. After that, I'd like you to spawn the particles using the mesh you specified. And lastly, try to apply forces to your particles based on the modules that you already know. See if you can create something interesting. Pause the video now and give this a go. Welcome back. How did that go for you? Hopefully that was easy enough for you to do. Now I'm going to apply some forces to my particles. So first, I'm going to change its looping behavior from once to infinite. And I'm going to delete the spawn burst instantaneous. Same as our sprite renderer, I'm going to use spawn rate. And I'm going to give it a random value, so somewhere between 5 and 15. Under this particle spawn, one thing to look for here is, so far we've only set size using this sprite attributes, but I'm sure you've noticed that no matter what values we put in here, this won't affect this mesh. And that's because in order to set its scale, we need to do it under this mesh attributes. And the sprite attributes is just for sprite renderer. So for this mesh scale mode, I'm going to change it to random uniform, and I'm going to give it a value to be between 0.5 and 1.1. And for the particle spawn, module shape location can be 5 and 1.1. And for the particle spawn, module shape location can be used for mesh renderer. And now you can see we are spawning these cubes in a sphere, and I'm going to use the same module at velocity. Now you can see we are slowly lifting these cubes up. I'm going to change it to in cone, and the cone axis I'm going to set a 0 for the x-axis and give the z-axis value of 1. And for the velocity speed, I'm going to give it a random value. So somewhere between 70 and 150. All right, something like that. I think the size of the cubes might be too huge, so I'm going to decrease the max scale from 1.1 to 0.8 maybe. And inside of this particle update, so the scale color is no longer affecting these cubes. And that's because the material of this cube, the particle color, is not used in there. So we won't be able to fade out this cube. So I'm going to delete this module, and instead I want to change its rotation. So you can see there's already a module, and it's called Update Mesh Orientation. After selecting it, you can see now I'm rotating these cubes. And for this rotation vector, I'm going to click this drop down, change this to a dynamic input. I'm going to select random vector, and now these cubes are rotating randomly. And the last thing that I want to do, I want to scale it. These cubes are to a dynamic input. I'm going to select random vector, and now these cubes are rotating randomly. And the last thing that I want to do, I want to scale it. So for sprite renderer, we can use scale sprite size to do it. But for mesh renderer, we need to use a different module. So it's called scale mesh size. And now you can see we get this scale factor. So now I want to decrease their size during their lifetime. There are two ways for me to do that. First, I can directly convert this vector from curve. In that way, I'll have control over each individual value. So I can scale its x, I can scale its y, I can scale its z. We're going to need this later for some VFX that we create. But for now, I'm going to select vector from float. Now you can see that vector has been converted into a single float. And now we can directly convert this flow into a curve. So I'm going to select flow from curve and use this curve that we've been using. Now you can see we are scaling our cubes. All right. I think this is what I need. I'm going to bring it into my level, see what it actually looks like. So I'm going to duplicate this demo display. And I'm going to change its name to Mesh Renderer. And I'm going to bring in my Niagara system. And just like that, now we are spawning static meshes inside of our Niagara system. How cool is that? So these are the modules that I use for my mesh renderer. Feel free to try them out yourself if you haven't used them before. And same as always, write down anything that you think are important on the demo. So these are the modules out yourself if cool is that? So these are the modules that I use as always extra. Lies within the ability to use custom mesh. We can use Niagara to spawn the meshes that we create in a 3D modeling software, and that could provide endless possibilities. If you've never clicked up mesh before, it's very common that we need to skip. So it's important that we get this wise. It'll be just a pain for us that it's 50 points UV. This mesh for the meshes are. But since it's really simple to adjust, why don't we just do it correct? This plan to face up. Point this is in is. Say now in it, then on. Now if I after selecting this mesh, I'm gonna go. So I already have my output folder spell plane on ground, and don't forget to export FBX that we're gonna create. So I'm gonna create a new folder, and I'm gonna call this one meshes, and to Unreal, and minimize this window. I'm gonna drag it inside to Unreal, and minimize this window. So I'm gonna keep everything above. of a default, and this material import method, I'm gonna select this drop down and choose do not. Now you can see the gizmo here is the pivot point of this mesh, and let's compare it with the mesh in Blender. So now hopefully you have a pretty good idea about the pivot point of the mesh in Blender. So by default, when you export a mesh from Blender and import it to Unreal, the pivot point will be at the Blender's world origin. It doesn't matter where the pivot point is inside of Blender. So right now, this mesh's pivot point is at the center of this mesh. But when we want to use it in Unreal, it will be at the world origin. So I'm going to move it back to world origin. We can easily do that by first selecting this mesh, then press O plus G. And this will cancel any of its movement and move it back to the world origin. Now I'm going to export this mesh again. So I'm going to go to File and choose Export, select FBX. And I'm going to overwrite this file. So click Export FBX and go back to my Unreal. We can just right mouse button click this asset and choose Re-import. And now you can see we have the correct pivot point for this mesh. And this is something that we can directly use inside of Niagara. And it's time for a challenge. So your challenge is, I'd like you to create two planes in Blender. So one plane will be on the ground, just like the one you saw, and another one will be facing the camera. What do I mean by that? So that means when I drag out the plane, I want its orientation to be facing the camera, something like this. So that means we need to have a correct orientation in Blender before we export it to Unreal. See if you can figure out which axis is which in Blender comparing to Unreal. Once you figure out which axis is correct in Blender, be careful with the pivot point for your planes. So for these two planes, we want their pivot point to be at the center of the mesh. And don't worry if you made the mistake or the orientation is wrong. Same as I did, you can always go back to Blender, export it again, and re-import it inside of Unreal. And last step, sample your own meshes in Niagara system. So after you have your planes ready, see if you can sample them inside of the Niagara emitters. Pause the video now and give this a go, or come back if you need help. It's facing the camera to add plane. Then we can rotate and figure gizmo here. That means we want this plane to have an orientation. So if we want it, so on this axis, I should have already changing control then for our UV. But it's a good to export its rotation back FM underscore back to Unreal. Alright, perfect later Niagara system to sample these two meshes. So go back to my Niagara folder. I'm going to create another folder. For this one, I'm going to call it 09 custom mesh and double click to open. It, create a Niagara system, go to Next, select Simple Sprite Burst. Change its name to ns underscore custom mesh and double click to open it. So first, I'm going to change its loop behavior to be infinite and delete this sprite renderer. Change it to mesh renderer. And inside of the meshes here, I'm going to select my SM underscore plane on ground. And you you can see here it is. Now I'm going to duplicate this emitter, and I'm going to change its mesh to SM plane face camera. And now you can see we can see the mesh, and that's because by default the mesh will be single-sided. And by applying the two-sided emitters by default face camera. And now you can see we can see the mesh, and that's because by default the face. Now I'm going to duplicate this emitter, and I'm going to change its mesh to SM plane face camera. And now you can see we can see the mesh, and that's because by default the mesh. Mesh will be single-sided, and by applying the two-sided materials to it, we can get rid of this backface issue. Right now I think this is good enough. I'm gonna put this Niagara system into my level. So I'm gonna delete this mesh and duplicate this demo display, and change its name to custom mesh, and dragging in this Niagara system, and just like that. Now we are sampling our own custom mesh. In this lecture, we went through the difference between pivot point for Blender and Unreal, and we also use Niagara system to sample our custom static mesh. Now that with the ability like this, by applying some custom materials to our mesh, we can achieve so many different types of VFX. And we'll look at how we can do that in the next lecture. I'll see you in the next lecture. Created these two custom meshes inside Blender, and we used Niagara system to sample these two meshes. Now, they are just two simple plans and they don't really look exciting. In this lecture, let's look at how we can create textures for them, and we'll be doing it all inside of Unreal. So, in Unreal, we can directly bake out textures, and to do that, there are two things we need. So first, we need a material, and second, we need the render target. The material here will directly determine the patterns on the texture. In other words, the content of it, and the render target will act as a container for us to bake out the texture. I'm sure you already know what a material is. Let's talk about this render target. A render target is used in many different ways inside of Unreal, and it's quite a powerful tool. So first, a material can draw to render target, and this behavior can be triggered by code. And what's best about it is this behavior can be done in editor or runtime. So for example, in editor, we can use it to help us to create some textures. And in runtime, it can achieve so many different types of in-game effects. Things like footprints on the ground, make a water surface interactive when a character walks into it, dynamically draw a texture onto the wall, and the list goes on and on. For our purposes here, we only want to use it to create textures directly inside of Unreal. So this is the texture that we'll be creating. You can see this is just a simple pattern, a simple ring. To do that, there are three things we need. So first, we need a material that contains this pattern. Then we'll need a render target. And the last thing, we also need a blueprint. Remember, this behavior is triggered by code, so we need to use blueprint to write some code to help us achieve this. Of course, a simple pattern like this can easily be created inside of Photoshop, but this lecture will be a perfect introduction for the things we want to do next. Alright, let's look at how we can set this up in Unreal. Go back to Unreal. Inside of my Niagara Basic folder, I'm going to create another folder. I'm going to call this 10 Simple Ring, and double click. click to open it. So first, I'm going to create a material that contains this ring. So I'm going to call it m_simple ring and double click to open it. So for a simple pattern like that, I don't need these many sockets. So I'm going to change the shading model from default lit to unlit. So I only need to have access to this emissive color.
Hey, this is me from the future. One thing here worth mentioning is that when drawing material to render target, only two sockets inside of material are valid. So they are emissive color and opacity. Later, when we draw this material to render target, only the values that go through the emissive color socket and opacity socket will matter in here. Other values in other sockets will just be ignored. So keep that in mind in the future when you want to use the render target yourself. Alright, back to the Omi.
Then I'm going to create my first primitive shape. And there's a material node that we can directly use. So that node is called radial gradient exponential. So what this node does is it simply generates a y dot with fall off. So I'm going to start previewing it and change the preview mesh to plane. So you can see this is what I get. And to get a ring, we can use one bigger dot to subtract a smaller dot. So first, I'm going to give it some function inputs. For the radius, I'm going to give it a default value of 0.4. And plug this into radius. Now you can see I have a smaller dot. And for its density, because I want my ring to have a harder edge, so I'm going to increase its density quite a bit. I'm going to use a default value of 100. And plug this into density. And now you can see I get a basic shape like this. Alright, I'm going to start previewing this node. Then I'm going to duplicate these three nodes, press Ctrl+ D. And for this one, I'm going to change its radius from 0.4 to 0.37. So I should get a smaller dot, and I'm going to use a subtract node in here. And plug this into the emissive color. And that's it. You can see now I have a ring. So these are the nodes and the values that I use for creating the shape we need. I'm going to pause here for 2 seconds. So if you want to follow along, you can pause here, go ahead and do this, or come back anytime when you finish watching this video. Alright, now after having the shape ready, next thing I need a render target. So I'm going to right mouse button click and go to textures and select this render target. So I'm going to name it to be RT_simple ring and double click to open it. Now, before we draw anything to a render target, it's important we set its properties first. So the first thing that I'm going to set is size X and size Y. So this will directly determine what kind of resolution our texture will have. So instead of 256, I'm going to change it to 512 and 512. And this resolution, I think, is more than enough. And I'm going to keep everything else at default, but I'm going to change the format in here. So instead of this RGBA16F, I'm going to change it to RGBA8 as RGB. So basically, this means the texture later we created will have 4 channels and also have this as RGB turned on. And this is the default setting for most textures we use in Unreal. And that's it. That's the basic setting for render target. So here are my settings for this render target. I'm going to pause here for 2 seconds and then we'll move on. Alright, now that we have a material ready and we have a render target ready, the next thing we need the blueprint to help us create the textures. And more specifically, we need the code inside of it. And in the next lecture, we'll look at how we can do that. I'll see you in the next lecture. Successfully set up a material and a render target. In this lecture, let's look at how we can use a blueprint to draw our material to render target. Understanding how blueprint works is essential for creating VFX because eventually we'll need to use blueprint to help us to spawn VFX as they are tightly connected to gameplay. And if we don't know anything about blueprint, we'll just end up with having a bunch of VFX that we don't even know how to use. So in this lecture, let's look at how we can write some code in blueprint. So go back to my editor, I'm going to go to this textures folder. Since this blueprint is highly related to textures, I'm going to put it in here. So right mouse button click and click blueprint class. So you can see here it's asking us to pick which class do you want to be the parent class for this blueprint. And depending on the class that we choose here, we could inherit different functionalities. For our purpose here, we only need to be able to place this blueprint inside of our level. So simply choosing actor here is enough. And you can see here it says an actor is an object that can be placed in the world. Alright, I'm going to click actor and I'm going to call this BP underscore texture baker and double click to open it. I'm going to go to this event graph, and instead of using events, I like to use functions. So we can create functions directly in here. So I'm going to click this add button to add a function, and I'm going to call this function bake texture. I'm going to go to the right in here, and under this graph section, I'm going to take this checkbox for call in editor. So what this does is, this allows us to call this function inside of our editor directly. And to prove this function is working, I'm going to use a print string. And the string, I'm going to change it to working and connect. I'm going to drag out this actor and lift it up a little bit. I'm going to press G now to show the icon of it. And you can see, lift it up a little bit. I'm going to press G now to show the icon of it. And you can see, inside of the details panel, we get a new button and show the icon of it. And you can lift it up a little bit. I'm going to press G now to show the icon of it. And you can see, inside of the details panel, we get a new button. And here it says bake texture. So this is the function name that I just set. After I click this button, you can see a string has been printed to the screen that I just set. After I click this button, you can see and string, I'm going to change it to working and connect this pin to here. and leave it inside of the details panel, we get a new button, and here it says bake texture. So this is the function name that I just set. After I click this button, you can see a string has been printed to the screen. Alright, this is working, and we can use this function to create textures directly inside of our editor. Now go back to this blueprint. I'm going to delete this node. So the function we need is called draw material to render target. And you can see it takes two function input. First one is this texture render target. Second one is the material. And we can use the drop down here to select which render target we want to use, which material we want to use. But before I set anything in here, there's one thing that I like to go over, and that is the function types for Blueprint. And this function is called add actor or rotation. Can you notice a difference between these two functions? So the function on the left, this is a non-static function, and the function on the right, this is a static function. And the difference between a static and non-static function is this word right here, the target. So to access a static function inside of Blueprint, as long as we know the name of the function, we can directly call it inside of the event graph. But to access a non-static function, we'll actually need an object reference. An object reference is just like a variable. We can use this object reference to call this function add actor or rotation. And that's because a non-static function only exists in the object that owns this function, and to access this function, we need to have a reference of this object. Otherwise, we just cannot call the function. And you already know that an object reference is just a variable that contains value. But for this object reference, it's empty. So we declare a variable that has a type actor. But this is just a variable. In order for it to work, we need to actually find a way to assign the value to it. In other words, the actor that we are trying to reference in here. And if we are trying to access an object that's not even there, we'll get a crash. So when we have an object reference in Blueprint, it's always important to check whether or not it's valid. So you can see this node here, it can help us to check this input object. And if this variable indeed holds the object that it's trying to reference, then this its valid pin will fire. And if it doesn't, then this pin will fire. And in C++, declaring an object reference is also known as creating a pointer. And an empty object reference is known as a no pointer. So always check your pointer in C++, always check your object reference in Blueprint. Now go back to my function. If you use your mouse hover over this function, you can see it says target is Gizmo rendering library. So most of the static functions exist inside of a library, and they are like global functions that we can access anywhere else we want, as long as we know the function name. In C++, that's the case, but in Blueprint, we'll have some constraint. But generally, the rule applies. Now, instead of selecting the value inside of the dropdown to make it a hard-coded value, I like to use two object references so that we can manually assign them different values, and we can use this to bake out any textures we like. So first, we can go to the variables here and click add. So by default, it will be a boolean, and it's to delete this. While a variable, once we mark it, I'm going to promote it to draw, and to variable we are passing two object changes do the same thing, so get to draw. And to variable material here, I'm going to do the same thing, so drag out this pin and select promote to variable, and I'm going to change its name into this function, and currently they are both empty. First, I'm going to click compile in here, so you can see we can assign them values in here, and they are both empty. So for a static function, passing in empty object references probably won't matter, because inside of this function, there will be code to prevent us from accessing empty object references, but it's always a good habit to check. So I'm going to drag out this render target to draw, and select get, and drag out this pin. I'm going to type is valid. So you can see we have two Boolean. It will be for our purposes here, it's going to use, we can combine Boolean. So here. So if I'm going to click here to again and material to draw from, and we can directly assign them value, right? I'm going to go back to my net. We can go back and to see under this big texture, I have a render target file again. Now go back to draw from to bake out other text. Go to this simple RT the material to the render target, and we can use the right mouse button click and select this create static texture. Just like that, we got ourselves a texture, and select this create static texture. Just like that, we got ourselves a texture. Now double click to open it. So this is what you will be seeing, a transparent background. And that's because we have alpha channel for this texture, and this alpha channel is overriding the RGB. If we disable this alpha channel, you can see this is the pattern. So I'm going to the RGB. We have big texture. Just like that, we got get to draw, fill in this RT simple and click this icon. And for the render target to draw, fill in this RT simple ring and click bait. Texture. And now you can see we are drawing the material to the render target, and we can use the right mouse button click and select this create static texture. Just like that, we got ourselves a texture. Now double click to open it. So this is what you will be seeing, a transparent background. And that's because we have alpha channel for this texture, and this alpha channel is overriding the enable back is compressed its resource size. So I'm going to take it, and now you can see we can see the texture. I'm going to close this window and go back to my level. So right now we can already draw a material to render target, and we can create textures from this render target, but we can make this function much better. So I'm going to first delete this texture, go back to my blueprint, so when I fire this function, not only do I want to draw material to render target, I also want to create a texture directly from it. And we can do just that. The function, and you can see this is a static function. It also belongs to this Kismet rendering library, and it has a few static function. Static texture. I'm going to select it, and you can see this is a static function. It also belongs to this Kismet rendering library, and it has a few function inputs. So first one, which render target should we use to create textures from? Well, that will simply be our render target to draw. So I'm going to get it and plug this into this render target. And the second one is the name. So what's the name for the texture. Instead of texture, I'm going to change it to texture from render target. And I'm going to keep this compression set settings at default, and this mid setting at default, and connect this pin to here, and click compile. Now go back to my level. When I click this button again, you can see a texture has been created. And I'm going to disable its alpha because we don't need it. Now go back to my level. I'm going to change its name to T_simple ring. And just like that, we have our texture baker ready, and it's time for a challenge. So a challenge is, same as I did, I'd like you to draw material to render target using Blueprint. After that, with the new texture you just created, see if you can use it in Niagara system with your custom mesh. Remember the two plans we created in Blender? Try to see if there's anything interesting that you can create based on what you have right now. So you already know how to assign custom mesh inside of a Niagara system for mesh renderer. See if you can figure out how to assign your material to it. And for the material, you can just use our single texture master and create a material instance from it. Pause the video now and give that a go. Welcome back. How did that go for you? Now I'm going to create some VFX using the texture that I just created. So inside of this folder, I'm going to directly create a Niagara system and select new system from selected emitters. And go down, select the simple sprite. First, and double click to open it. So first, I'm going to delete mesh. To SM_plane face camera. Now this is simply just a flat plane, and I want to apply some materials on it. So I'm going to click this enable material overrides and click this button here to add an element. So in here, we can specify what material we want. So I'm going to go back to my material folder, and I'm going to select this single texture master, create a material instance from it. I'm going to call it mi underscore simple ring additive and move it to the folder. So I'm going to drag it to this simple ring and click move here. Now double click to open it. So I'm going to swap out this dandelion texture and I'm going to select this simple ring in here, click this main texture and click this icon. Alright, now we have our material spread. Ready. And just to make it look even better, I'm gonna take this shoot change brightness. Then I'm gonna go back to my Niagara system. So select this mi simple ring additive and click. Click this icon here to use that material. And you can see now we have our ring in here. So I'm gonna first change its loop behavior from once to infinite. And so I'm gonna first change material and you can mi simple ring additive and click this icon here. Niagara system. I'm gonna take this shoot change brightness. Then I'm going to go back to my Niagara system. So select this mi simple ring additive and click this icon here to use that material. And you can see now we have our ring in here. So I'm going to first change its loop behavior from once to infinite. And for its initial color, I'm going to give it something maybe orangish. And increase its value to 5. Now you can see it's glowing. And just to add a little bit of flavor to 5. Now you can see it's glowing. And just to add a little bit of flavor inside of particle update, I'm going to use scale mesh size. And after I add the module, you can see we cannot see the particle anymore. And that's because in order for this module to work, we need to first set the mesh scale in here. So instead of unset, I'm going to change it to uniform. And now we have our particle back. Inside of this scale mesh size, I'm going to click this drop down in here and select vector from float. Then I'm going to convert this float to a curve. Now you can see our plane is shrinking. That looks like our ring is shrinking. And we can change the curve in here depending on the result that we want. So if I change it to this curve, we'll get an effect like this. Or if I change it to this, we'll get an effect like this. I think I'm going to go with this one. All right, I'm going to go back to my level, and I'm going to drag this Niagara system. All right. I'm going to go back to my level, and I'm going to drag this Niagara system into my level. So first, I'm going to increase the length from 10 to 13, maybe, and duplicate. This demo display current system. I want to do a representation so that when we hide the error, it is here. And I like to give it some visual representation so that when we hide the icon, we can still see it. And I like to give it some visual representation so that when we hide the icon, we can still see it. And to do that, we can add a component to it. So I'm going to click this edit bp_texture_baker. And inside of this component section, I'm going to click add. The components that I'm going to add would be a text component. So you can see it's called text render. And go to my viewport. So this is what it looks like. Now I'm going to change its content from text to texture baker. And I'm going to rotate it a little bit. So I'm going to rotate it 90 degrees and I'm going to increase its font size. So instead of 26, I'm going to change it to maybe 35. And click compile. Now go back to our level. You can see we have a visual representation of our texture baker. Now I'm going to move it to this demo display. And now if we hide the icon, we can still see it. And if we want to click it, it will be much easier. easier for us to do so. In this lecture, we successfully drew material to render target, and we also went over some basic coding principles inside of Blueprint. And after that, we also used our created texture on the custom mesh that we created. Great job! I'll see you in the next lecture. Welcome! In the last lecture, we successfully set up this texture baker and we applied our created texture to our custom mesh. Now that you already know what the mesh renderer could do, in this lecture, we're going to look at how we can use the ribbon renderer. So first, I'm going to go back to this basic filter and I'm going to create another one. I'm going to call it 11 ribbon renderer and double click to open it. Inside of here, I'm going to create a Niagara system and select this new system. Go to Simple Sprite Burst and click Finish. So I'm going to name this ns_ribbon renderer. Double click to open it. So by default, when we choose this Simple Sprite Burst to start, it will be using this sprite renderer. And we can delete this and add the renderer we want. So we are going for this ribbon renderer. And after we do that, you can see we cannot see anything. There's no particle inside of our world. Actually, there's already particle in there, but just because of the special features of this ribbon renderer, we cannot see anything. First, I'm going to set this loop behavior from once to infinite. Then I'm going to drag this Niagara system to my level. So I'm going to duplicate this demo display and change its name to ribbon renderer and drag in this Niagara system and lift it up. So right now, we still cannot see anything, and that's because we need to increase its spawn count. So I'm going to delete this instantaneous and add in spawn rate. So the default number Unreal uses is 100 for ribbon renderer. I'm going to be doing the same thing. Alright, that's the spawn rate taken care of, and there's one more thing that we need to set, and that is the width of the ribbon. So we can do that by either going to this ribbon attributes, or we can click this button. So for this ribbon width mode, I'm going to change it from unset to direct set. And for its width, I'm going to go with 10 for now, and go back to my level. And now, if I drag this Niagara system, you can see, we can see this ribbon. And right now, its color is at its default color, so I'm going to change its color. Go back to this all. I'm going to change its initial color to something orangish and increase its value. And click OK. Now we have moved this Niagara system again. Now you can see we get a colorful ribbon. And the most general use case for this ribbon renderer is actually something like this. So first, I'm going to go to this third person folder and go inside of this blueprints. And double click to open this BP_ third person character. Alright, after getting inside, I'm going to click Add here to add a component to this character. You can see by default, a character already has many components. I'm going to add one more, and the component is called Niagara. Particle system component. So I'm going to select it, and I'm going to leave its name at default. And for this Niagara system, I'm going to use this ribbon renderer. So I'm going to go back to Niagara Basic. And select my ribbon renderer and click this icon here to use it. Now, after we do that, this Niagara system will be attached to our character. I'm going to click compile in here and go back to my level. So I'm going to change my world settings in here. So go to my word settings for this game mode override. I'm going to select this BP third person game mode. So now when we click play, we'll be using that character. Alright, I'm going to click play. And I'm going to begin to move. Now I think you already have a pretty good idea at what this renderer could do. So what does this mean? And that's the most basic attributes of this ribbon renderer. So it can achieve what the other renderers couldn't do. Draw emitter, then I set a person character to try this, forget to change. Alright, now that we know what this ribbon renderer could do, but that's not all of it. There's another that is very commonly used. So I'm going to go back to this ribbon renderer folder. Click Niagara System and click Next. Inside of all these templates, we have this dynamic beam and this static beam. So for these two emitters, they are both using the ribbon renderer as well. So I'm going to first use this static beam and click Add, click Finish. I'm going to name this to ns_static beam and double click to open it. And now you can see this is what this emitter looks like. And these are the modules it uses. So this is already set to be infinite. And we have these other modules that we can use to adjust its properties. And there are so many types of different effects that we can create just by this. And it's time for a challenge today. So your challenge is, I'd like you to adjust its modules. How did that go for you? Hopefully that was easy enough for you to do. So for example, if we want to adjust its length, so if I increase its value now we get a much longer beam. If I decrease it, we get a much shorter beam. And we can also take this use beam tangents. And if we do that, we will get something like this. So how this can be used in games, for instance, we can use it for the projectile's trajectory. And if we want to do it again, decrease it, we increase the spin emitter setup, and we can adjust its spin end in here. So if I increase its value now. Now we get a much longer beam. If I decrease it, we get a much shorter beam. And we can also take this use beam tangents. And if we do that, we will get something like this. So how this can be used in games, for instance, we can use it for the projectile's trajectory. And if we want to do that, using dynamic beam will be much better than this static beam, because the tangent of the dynamic beam can be calculated every frame. So I'm going to untake this use beam tangents. And I'm going to go to this initialized particle. So we can determine its lifetime in here. And there's not much we can do inside of this spawn beam, but inside of this beam width, this is how, and there's not much we can do initialized particle. So we can determine its lifetime in here. And there's not much we can do inside of this spawn beam, but inside of this beam width, this is how we can adjust its width. And by taking this curve, we can get the beam shape that we like. So now you can see I get a shape like this, and we can add a key to this curve by pressing the middlemost button. And if I lift this key up, now you can see the width of this beam has changed. And if we want to delete this key, we can select it and press delete on our keyboard. Now I'm going to lift this key up, and I think I'm going to add the key at the end. And first I'm going to select it and press 1 on my keyboard to convert it into a smoother curve. And I'm going to lift this key up until I have something like this. Maybe it's beam width, so 15, and we can go to this particle update, so increase its value to 10, and I'm going to change it to, we can go to this particle update, so this is its default color. I'm going to change it to something like this, and increase its value to 10, and click OK. Alright, something like that. Now I'm going to drag it into my level. So I'm going to drag in this NS static beam and lift it up. And press G on I want to use it, then adjust. It still doesn't look very exciting for this pump. Generally, we want to use our own material to achieve different types of game effects. And in the next lecture, we'll look at how we can build a material like that. I'll see you in the next lecture. Priority of Welcome back. This will just be a short lecture to prepare you for the material that we want to create next. So if you are from my material course, this should be no problem for you. And in case you aren't, this lecture is going to better prepare you for what's coming next. So first, I'm going to duplicate this demo display, and I'm going to rotate it and move it to the other side of the wall. And I'm going to change its name to UV manipulation. And after that, I'm going to drag out of the planes that we created inside of Blender. So it'll be this plane face camera, and I'm going to rotate it 180 degrees so that it faces this side. And I'm going to move it up. So this will be the preview plane that we use later. And inside of my Niagara folder, I'm going to create another folder. I'm going to call this examples. So later, if we need to make more examples, I'm going to put them all inside of this folder. And double click to open it. I'm going to create a material. I'm going to call this m_UV example. And double click to open it. So first, I'm going to create a texture sample node. And I'm going to select the texture in here. So the texture I'm going to use will be that T_simple ring, and plug this into the base color. So now we get this simple ring, and we can manipulate the UV of this texture by using the node texture coordinate. So the first thing that I like to do will be control styling. So I'm going to hold down M on my keyboard, bring out this multiply node, and inside of the socket B, I'm going to use a scalar parameter. So you can hold down S to do that. I'm going to name this UV tile and give it a default value of 1. Plug this into socket B. Plug this into UVs. Alright, I'm going to click apply, go back to my level. I'm going to create a material instance from it, and I'm going to call this MI_UV example. And I'm going to assign the material instance to this plane. So drag it inside. And we can control the UV tile inside of the material instance. You can see right after I increase the value, the texture tiles more. And if I decrease the value, the texture tiles less, and the pattern gets larger. So I'm going to reset back to 1. So that's the first important concept, UV tile. Now go back to my material. The second thing that we can do is UV offset. And it's very similar as this setup. I'm going to select this texture coordinate and duplicate it. And I'm going to use an add node. So I want to have the ability to both offset this texture horizontally and vertically. So we can do that by creating 2 more scalar parameter. I'm going to call this U offset and duplicate this node. I'm going to call this V offset. And there's only one socket. We can combine these 2 scalar parameters together by using the material function make float2 and plug this into Y, plug the result into the socket B, and plug this into UV socket and click apply. Go back to my level. Now inside of my material instance, I can offset U and V individually. So you can see now I'm moving this circle horizontally, and if I change the value for V offset, I'm moving the circle vertically. And this is another important concept for the material we want to create next. And these are the nodes I use. So I'm going to quickly comment them. So these 3 nodes, they can control the UV tile. And these nodes below, they can control UV offset. So as an optional challenge for you, if any of this is new to you, feel free to go try this out for yourself. So same as I did, you can duplicate another demo display and then drag out material in, go pause, work to control this texture, and I'm going to note T_noise. So if this make T_2 step and 1, and if we T plug to this R1, that's how we can easily do that by the divide node. Increase it to this another important technique that we're going to use. You can B socket become 0.5, and if I plug this into socket B and increase the values inside of the B socket, so say I increase it to 10, and now you can see we can get a result like this. And this is another important technique that we're going to use later by using a noise texture to distort another texture. And that's not the only usage of a noise texture. We can even use a noise texture to dissolve the original texture. So you already know that it only contains a value ranging between 0 and 1. If I multiply the RGB with the red channel from this texture, what's the result going to be? Let's figure out. So I'm going to connect this into the base color. And now you can see this is what I get. So for the black values, because they have a value of 0, so we won't be showing those areas. And for the white values, since they have a value of 1, we'll still be showing those areas. So a noise texture can also be used to dissolve a texture. I'm going to drag this nodes down a little bit. And there's one more thing that I like to mention. Now already we have a bunch of nodes, and for the material that we want to create next, if we don't organize it, it's going to get complicated and messy very soon. And to do that, we can assign different parameter groups to the parameter inside of the material editor. So say right now, I convert this to a parameter and I call it main texture. So I can assign a group in here. So now I'm going to give it a group of 01 main texture. And the sort priority here will determine which row this parameter will be shown. So I'm going to say to have a sort priority of 1. And I'm going to convert this into a parameter as well. I'm going to call it distort texture. And I'm going to give it another group as well. I'm going to call it O2 distort and give it a sort priority of 1 as well. And I'm going to convert this into parameter. I'm going to call it dissolve texture and change its group to O3 dissolve and change its sort priority as well. So the number here doesn't really matter if we only have one parameter inside of this group, but it's gonna matter a lot when you have a lot of parameters. And now if I click apply, go back to my material instance, you can see all these three textures, they have been put into the groups that we just set. And these are the nodes that I use to achieve the things that you just saw. So if this is completely new to you, feel free to pause the video here and go try this out for yourself. And these will be the things we need next when we create the material for our VFX. Alright, go try this out for yourself if you need, and I'll see you in the next lecture. Create another. So the stick that I like to do will be control styling. So I'm going to use UV time, and we can control the UV dial inside of the material instance. You can see right after I increase the value, the texture tiles more. So we can hold down and here and I'm going to create a material. First, I'm going to create a texture in here. So the texture I'm going to use will be that simple ring, and plug this, and we coordinate. And then hold down M, a tile. Assign the material. I'm going to use E dip and U and V in the no the UV. So as an option. optional challenge as your preview mesh. Then create this node, what they'll actually do. Scalar parameter. To control the and I'm gonna note BT. So I'm gonna this make sure you use the default in here. So E underscore noise. So you can see this is the default show engine content enabled. So I'm gonna same as between 0 much more random. Use the RGB green or blue channel. It really doesn't matter. They all contain the same value. Use the RGB so noise text. So I'm gonna same engine we could get here. You can the same value. I'm using a noise texture. Plug green or blue channel, it really doesn't matter. They all contain the same value. All right, I'm gonna plug this into the UV socket, and you can see this is what I get. I'm using a noise texture values there, and that's how we. So that means like this. And right now, the texture itself strength. Generally, if I plug this into socket B. And increase the values inside the B socket, we can get by using of. So you already know that it only contains a value ranging between 0 and no texture. Multiply the RGB with the value dissolve the original texture. Stage of a noise texture, we can even use a noise texture to dissolve the original texture and multiply. What's the result gonna be? Let's figure out. So I'm gonna connect this into the base color. And to detect dimension, now already we have a bunch of nodes and a massive very soon out of the material editor. So say right now I convert this to a parameter and I call O1 will be shown. So I'm going to say to have a priority of 1, and I'm going to convert this into a parameter as well. I'm going to call it distort and give it a sole priority of 1 as well. And I'm going to call it O2 distort and give it a sole priority of 1 as well. And I'm going to convert this into parameter. I'm going to call it dissolve texture and change its group to O3 dissolve and change its sole priority as well. So that is going to matter a lot once you can see all these. And now if I click apply, go back to my material instance, you can see all these 3 textures, they have been put into the groups that we just set. And these are the nodes that I used to achieve the things you just saw. So if this is completely new to you, feel free to pause the video here and go for our Welcome! In this lecture, let's look at how we can create material so that we can swap out this default. So feel free to come back to use them as a reference if you ever get. Welcome! In this lecture, let's look at how we can create material so that we can swap out this default ribbon material to make this ribbon renderer much better. So this is the effect that I'm going for, and you can see, comparing to that default ribbon material, I'll have holes and have different patterns on the VFX itself. And to achieve this, we'll need three textures. So first is this main texture, and this will directly determine the look of this VFX, and we'll need two other noise textures, so they will be responsible for distortion and dissolving. So let's get hold of this main texture first. So this is another texture pack that we're gonna import, and it's another permanent free pack. Inside of it, there are a bunch of VFX made by the old Cascade system. We are not interested in those, but we will be using the textures that this pack can provide. So you can see under the supporting engine versions, it does not support 5.1, but that doesn't matter. You can just add this 5.0 version to our project. So I'm going to click this add to project. So make sure you have ticked this show all projects, and I'm going to select 5.0. The move out is text under this effects folder. And if you scroll down, you can see there's this effects underscore textures. I'm going to move this out. So I'm going to drag it to our own textures folder. And click copy here. After that, I'm going to go to File and click Save All. And go back to my textures folder. I'm going to rename this to be infinity underscore VFX textures. And double click to open it. So this is a massive texture pack, and we're pretty much covered for all kinds of VFX that we want to create by using text. And we have textures for eyes. Under this effect, inside of it, there are, so I'm going to go to open this effects for VFX effects now. Alright, after that, I'm going to delete this folder. So I'm going to go to File, click Save All again, then right mouse button click my content folder and click this Show in Explorer. After that, I'm going to close my project and click Yes. After that, I'm going to restart my project. Alright, now, after having all the resources, let's start to build our own material. So I'm going to go to my material folder, right mouse button click. And click material. I'm going to call this m_pen distort master underscore additive and double click. To open it. So first thing first, I'm going to change its blend mode to additive, change its shading model to unlit, and I'm going to bring in a texture. So the texture that I'm going to use will be from that Infinity pack. It will be under this file folder. And I think this one works great for the static bin and the ribbon renderer. So I'm going to drag this texture into my material folder and connect its RGB to emissive color. Change the preview mesh to plain. So this is what I get. All right. First thing, I'm going to convert this into a parameter so that later if we want to use it for other VFX, we can just swap out this texture. I'm going to call this main texture, and I'm going to put it into its own group, so it'll be O1 main texture. And set its top priority to be 1. And next, I'm going to use the panel. So I want to scroll this texture. And for the speed X and speed Y, I like to have two parameters to control it. So hold down S on my keyboard. So this one, I'm going to call it main texture U speed. And give it a default value, V speed. And 2 to combine, we also want to put them into their corresponding group. So inside of group, I'm going to select this O1 main texture. So priority for this parameter will be 2, and for this one, it will be 3, all right? And connect this pin into UVs. And now you can see we are slowly scrolling this texture. And I'm sure you can see that inside of the panel now, there's another socket for texture coordinate. And this is where we can distort this texture. And for that, I'm going to bring out another texture sample now. And I'm going to change its texture to T_noise. And if you scroll up, you can see from the pack that we just imported, it already contains a few noise textures. We're not going to use them now. Instead, I'm still going to use this noise texture from engine and select it and convert this into a parameter. So I'm going to call this distort texture and put it into its own group. So it'll be O2 distortion and give it as a priority. Of number 1. And same as the main texture, I like to scroll this distort texture as well. So I'm going to duplicate this panel node, plug this into the UV socket, and same as below, we need 2 more parameters. Hold down S to create 2 speed, put it into its own group. Create this distort texture and make setting for the distort texture. And in order to have the distortion, we need to use the texture coordinate node, and we can use an add node here. So the value that we're going to add will be from here. So instead of connecting the pin right into here, I like to use a name reroute node. So basically, this can cache the value coming out of this node, and we can use this cached node anywhere else. So I'm going to call this cached distort texture output, and I'm going to use that cached node instead. So bring it output. And I'm going to cache the value, use a name reroute node. So basically, anyone, I'm going to use that cache the node instead. So bring it out and connect this into use that cache the node instead. So bring it out and connect this into the socket B. And move these 3 nodes down a little bit and drag them down, connect this into the coordinate node. And now you can see this is what I get. So right now the distortion is too much. So that means we need to add some values to control the distortion amount. And we can do just that. So inside of this distort texture, I'm going to drag this pin out and use a divide node. And I'm going to use a parameter to control the amount that we should decrease. So I'm going to bring out another parameter. I'm going to call this strength decrease amount and give it a default. Value of 5 to begin with, put it into its own group, O2 distortion. And for the sort priority, I'm going to set it to 5. And plug this into this B socket. Alright, instead of plug the output of this directly into this cached node, I'm going to add a switch parameter. And that's because not every noise texture we're going to use this switch parameter. And connect this into 4. false, and connect this into the output socket, and I'm going to give it a default value of true. And now you can see this is what we get. And before I forget, I'm going to put this switch parameter into its own group. So I'm going to put it inside of this O2 distortion and give it a sort priority of 4. So this will be above. This will be parameter. And I'm going to quickly comment out these nodes. So this will be distort texture. And I'm going to click apply. Let's see what this looks like inside of our material instance. So go back to my level, go to my material folder. I'm going to create a material instance from it. And I'm going to call this mi underscore ribbon underscore additive. And move this to the ribbon renderer folder. So drag it to this folder and select move here. Now go inside of this folder. I'm going to open this NS static bin. And I'm going to swap out this material material. So I'm going to select it and click this icon in here. And you can see right now we get a completely different look. And the reason why we are losing the color is we are not using the particle color node. So let's fix that. Go back to my material. Same as above, I'm going to cache the output from the main texture. So I'm going to drag out this pin and use another name reroute node. I'm going to call this cached main texture output and disconnect that pin. And I'm going to quickly comment these these nodes, that particle. So I'm going to call them main texture. Now I'm going to bring out that particle color node. So type particle color and use the catch the main texture output. So multiply it with the RGB and plug this into socket A and plug this into the emissive color. And now we should have control over the color inside of Niagara system. Click apply. Go back to my Niagara system. Now you can see we have the color back. I think I'm going to change it to something purplish and click OK. Yeah, something like that. And if we go back to our level, this is what we get. Alright, we already have some interesting flavor over this particle effect. And let's finish. That material. So besides the particle color, we also need to plug something into the opacity socket. And let's go back to this texture. So if I clicked this magnifying glass and go to where the texture is located, double click to open it. And by default, it already has alpha channel. So if we isolate all these different channels, the values inside of alpha channel, we can use it as the opacity mask. But this isn't always the case. For the textures that we're going to use later, some of them may not have the alpha channel. And if that's the case, we'll need to deal with it differently. But for now, for this one, we can just use the alpha channel. So go to where this main texture is located. I'm going to use another name reroute node in here. I'm going to call this cached main texture alpha output. And I'm going to use that cache the node down below. So we can select it and use a multiply node to convert them together. And plug this into the opacity socket and click apply. Go back to my level and plug this into the opacity socket and click apply. Go back to my level. I think I need to increase the width of my bin quite a bit. So go back to my Niagara system. Under this bin width, I'm going to give it a default value of 50 and go back to my level. Yeah, something like this. So one last thing that I like to add would be the dissolve texture. So we can use a noise texture to dissolve this main pattern. And to do that, I'm going to use the same noise texture as a parameter, and we can always swap it out later. So I'm going to change its name to dissolve texture. And change its group to 03 dissolve. And for the dissolve texture, I'm going to be doing the same thing. So I want to pan it. Plug this into the UV socket. And I need two parameters to control its speed. So hold down S to bring one. I'm going to call it dissolve texture uSpeed. And put this of 2. I'm going to parameter. I'm going to call this dissolve texture vSpeed and give it a default value of 0 and change its salt priority to be number 4 and use a make float 2 to combine them together. And plug this into speed. Alright, same as above. I'm going to cache its output. So I'm going to cache this red channel, and I'm going to call this cached dissolve texture output. And down below, we can use the values from there. So I'm going to directly below, we dissolve a parameter, and we can always swap it out later. So I'm going to change its group we can always swap it out later. Noise to dissolve this main pattern, the dissolve texture. So we can use a noise texture to dissolve this main pattern parameter, and I'm going to give it a default value of, I'm going to cache its output now. So the dissolve amount 1. So to control the dissolve strength, we can use alert no to do that. So if the value inside of the alpha is 1, then the value inside of socket B will go through. And as we grow, the value final opacity max. So multiplying one wouldn't really change anything to the final. No opacity mask. And I'm going to put this parameter into its own group, so it will be over 3 dissolve. And that sort priority, I'm going to change it to 4. And there's one more thing that I like to do. So for this dissolve amount, I like to clamp its value. So you can see in here we have slider min and slider max. I'm going to change this slider max to be 1. So later when we adjust this in material instance, it can only go as high as 1. Alright, I'm going to click apply, and let's see what this material instance looks like. So go back to my ribbon renderer, open this material instance, and you can see this is what we get. with 3 groups and 3 textures. texture parameters. I can change that, but I'm gonna enable the row to here and take this real time. And you can see the texture we can take. If I change it, this is what we get. So we can get a completely different look. And for this dissolve texture, this is what I get. And if I change the value of dissolve amount to 0, now we get completely no dissolve. So I think the value for 08 to 0. You can see this is what we get. And if I change it to 10, this is what we get. So we can get a completely different look. And for this dissolve texture, we can also change how fast it moves as well. So if I change the value to 1, I'm going to call this dissolved amount. And I'm going to give it a default value of do that instead of 2. And and I'm going to put priority of this dissolve, change it to its own group. So and so one more thing that I like to solve for. So determine and just there and distance, and you can see this instant you can change the view dissolve mask. And I'm going to multiplying the A, say 1. We can bring up my with 3 groups and 3 texture parameters. Now let's try to adjust this value. Say now I want my main texture to get distance view. See the amount strength. I change it to 10. This is what we get. So we can get a completely different look. And for this dissolve texture, we can also change how fast it moves as well. So if I change the value to 1, this is what I get. And if I change the value of dissolve amount to 0, now we get completely no dissolve. So I think the value for 08 will suffice. And I'm going to decrease this main texture USB. change it back to 0.2 maybe. Alright, something like that. Now that with a material like this, not only can we use it for ribbon renderer, we can also use it for the VFX that we're going to create later. And I'm sure you can already notice the importance of a noise texture for VFX. A different pattern could totally alter the look of the VFX, so having different types of noise texture can help us to achieve more interesting variations. And in the next lecture, we'll look at how we can create noise textures directly inside of Unreal. Alright, let's do a little bit of recap. So this is all the nodes that I use for my distort texture, and if you look closely at it, there's really nothing too fancy. All I did was use panner node and use two parameters to control how this texture should be panned, and add another switch parameter to decide whether or not we want to decrease its amount. And these are the nodes that I use for main texture and the dissolve texture, and they both use the similar setup as our distort texture, so feel free to come back to use them as a reference if you ever get stuck at creating your own materials. And finally, I combined all of those nodes together with this particle color node so that we can control its opacity and color inside of Niagara system. And this is my end result with a material instance looks like this. So take your time, and it's time to create your own pen distort master material. I'll see you in the next lecture. is just another tool. Welcome! In the last lecture, we created this pen distort material, and we created this material instance based on that. And we also used this to swap out this default ribbon material, and we get a VFX like this. In order for us to see better, I'm going to increase the lifetime of this static beam. So I'm going to right mouse button click and click this edit. And go inside of it, I'm going to go to this initialize particle and increase its lifetime to 5 seconds. And now, I should always have this static beam inside of my level. And we can also swap out, always have this static beam inside of my level. And we can also swap out the material for this ribbon renderer. So I'm going to go to the material slot and I'm going to select this mi_ribbon and click this icon in here. And I'm also going to increase its width a little bit. So right now the ribbon width is 10 units. I'm going to increase it to maybe 50. And if I click play now, you can see already we have something much cooler than the units. I'm going to increase it. Increase. And we can also swap out the material for this ribbon renderer. So I'm going to go to the material slot and I'm going to select this mi_ribbon and click this icon in here. And I'm also going to increase its width a little bit. So right now the ribbon width is 10 units. I'm going to increase it to maybe 50. And if I click play now, you can see already we have something much cooler than the original ribbon material. But we have one issue with this kind of setup, and that is for the distortion texture and the dissolve texture, we are both using the same noise texture, and that isn't really too ideal. Wouldn't it be nice if we have many options for us to choose, and by applying different types of noise texture in here, we can get a totally different look. So generally, to create a noise texture, we will use softwares like Photoshop or Substance Designer. But since we already have a texture baker ready, we can do that inside of Unreal directly. So the first noise texture that we are going to create is something called Perlin noise. So this type of noise pattern is named after the person who invented it, Ken Perlin, and it is used widely in games for different purposes. In this lecture, let's look at how we can create a noise like this inside of Unreal. Go back to my level. I'm going to go to the textures folder. Inside of it, I'm going to create another folder. I'm going to call it noise. Double click to open it. Under this folder, I'm going to create another one. I'm going to call this Pauline noise. Double click to open it. Right away, I'm going to create a material. I'm going to call this m_Perlin base. In case you forget, in order to bake our texture, we'll need a render target and a material. So I'm going to create a render target directly. Go to textures and select this render target. I'm going to call this RT_Perlin base and double click to open this material. First thing, I'm going to change the shading model from default lit to unlit. The texture we are creating is a noise texture. We only need to have access to this emissive color socket. So to change the shading model from default lit to unlit. The texture we are creating is a noise texture. We only need to have access to this emissive color socket. So to create a noise texture, we first need to use the node noise. And if I right mouse button click and start previewing it and change the preview mesh to plane, you can see what this node does is it generates a bunch of tiny nodes, and by tweaking some of the values here, we can get the result we want. So first, we need to plug something into the position socket, because the thing we are after is we want to bake out this pattern to a texture. For this position socket, we need to constrain it to texture space, and they'll require us to use the node texture coordinate. And if we plug this into the position socket, you can see we get an error message. And if we use our mouse hovers over this, you can see it says cannot cast from type flow 2 to type flow 3. So the position socket is looking for a flow 3, but the texture coordinate node, it outputs a flow 2. And in order for this to work, apparently we need to add one more value to this, and we can use the node append to do that. So I'm going to use the node append vector. And for now, I'm simply going to pass in another value, a value of 0, and plug this into the position socket. And after that, you can see the error message is gone, and we already can see some type of noise pattern. Alright, this is great. We're getting somewhere. And next thing we need to tweak is the settings inside of this noise node. So if you look inside of it, there are quite a few things that we can tweak, and it might look quite intimidating at the beginning. So let's do it step by step. So first thing, we need to choose the correct type to begin with. and we can do that inside of this function. And I'm going to use a number. So I'm going to let the result I get for this. For a noise is usually up to the power node. Start previewing you keep just the edge sharpness. So this I'm going to keep it inside of this. I'm going to name format u offset use and concept and see that this pin touch. I'm going to random variation. So if I increase the u offset, this is a totally different noise gate. So now by I'm going to call this and hi. So I'm going back to do that render tutorial instance to fucking this button directly by a different noise node, and these are if you need, and it's different noise. Change the textures of typing the name about the file VFX of it. So you select and make our light disable to this both the selected asset and take. I go back to right now. We get to my. I'm going to use become and increase always create attempting to large enough to control that whether or not if to control it. You can set it and the correct naming click.
One that I use the material. A window will pop this. If you want example, I'm like naming convention this menu with the old and
Softwares like Photoshop or Substance Designer. But since we already have a texture baker software, get the total. Go inside of it. I'm gonna go to this initialize particle and I shoot material slot and some way now the original ribbon material. For the distortion texture and the dissolve texture, we are both using the same noise texture, and that isn't really too ideal. Wouldn't it be nice if we both, that is for the distortion texture and the dissolve texture, we are both using the same noise texture, and that isn't really too ideal. Wouldn't it be nice if we have many options for us to choose, and by applying different types of noise texture in here, we can get a totally different look. So generally, to create a noise texture, we will use softwares like Photoshop or Substance Designer. But since we already have a texture baker ready, we can do that inside of Unreal directly. So the first noise texture that we are going to create is something called Perlin noise. So this type of noise pattern is named after the person who invented it, Ken Perlin, and it is used widely in games for different purposes. In this lecture, let's look at how we can create a noise like this inside of Unreal. Go back to my level. I'm going to go to the textures folder. Inside of it, I'm going to create another folder. I'm going to call it noise. Double click to open it. Under this folder, I'm going to create another one. I'm going to call this Perlin noise. Double click to open it. Right away, I'm going to create a material. I'm going to call this m_Perlin base. In case you forget, in order to bake our texture, we'll need a render target and a material. So I'm going to create a render target directly. Go to textures and select this render target. I'm going to call this RT_Perlin base. And double click to open this material. First thing, I'm going to change the shading model from default lit to unlit. The texture we are creating is a noise texture. We only need to have access to this emissive color socket. So to create a noise texture, we first need to use the node noise. And if I right mouse button click and start previewing it, and change the preview mesh to plane, you can see what this node does is it generates a bunch of tiny nodes, and by tweaking some of the values here, we can get the result we want. So first, we need to plug something into the position socket, because the thing we are after is we want to bake out texture space. And if we plug this into the position socket, you can see it says cannot cast from type flow 2 to type flow 3. So the position socket is looking for a flow 3, but the texture coordinate node, it outputs a flow 2. And in order for this to work, apparently we need to add one more value to this, and we can use the node append to do that. So I'm going to use the node append vector. And for now, the position socket. And after that, you can see the error message is gone, and we already can see some type of noise pattern. Alright, this is great. We're getting somewhere. And next thing we need to tweak is the settings inside of this noise node. So if you look inside of it, there are quite a few things that we can tweak, and it might look quite intimidating at the beginning. So let's do it step by step. So first thing, we need to choose the correct type to begin with, and we can do that inside of this function. Right now, it's set to be the simplex texture based, and in order to get the Perlin noise, we need to change it to this gradient texture based. And if you ever feel confused about what these functions can do, the description text here is usually a big help. So this gradient texture base can help us to generate the Perlin noise we want. So I'm going to select it, and I'm going to begin to tweak some of the values in here. So first thing, the scale here. This will directly determine the scale of our noise, and I'm going to use a number of 8 to begin with. And now you can see we're already getting somewhere. And since we will be using this noise texture inside of our VFX, and we are likely to scroll it, that means our noise texture needs to be seamless. And we can easily do that by using this node. So after setting the scale, if you go down, you can see there's an option for tiling. If you take this, and then the repeat size here, you can just set it to be the same number as your scale. So I'm going to change it to 8 as well. And this will guarantee that you'll get a seamless noise texture. Alright, after adjusting the repeat size, the next thing, I'm going to start with this turbulence. So I'm going to untake this turbulence, and you can see this is the result I get. And for this level, so this will directly determine the amount of details for our noise texture. If I change this number to 1, you can see my noise texture, it becomes quite blurry. And if I increase this value, I have more details for this texture. So generally, I think a number of 5 will I have texture, it becomes quite blurry. And if I increase this value, I have more details for this texture. So generally, I think a number of 5 will simply do the job in here. And let's go down. So we have this output min and output max. This will determine what's the value for the output result. For this output max, a value of 1 is fine. But for the output min, for a noise texture, we generally want it to stay between 0 and 1. So I'm going to change this output min from -1 to 1. And the last thing we can adjust is this level scale. And you can see here it says usually 2. So I'm going to keep it at 2 in here. And we can directly draw this material to our render target. But before I plug this into the emissive color, I like to add 2 more nodes to adjust that. So the first node I'm going to use is the power node. So what this node will do is it can help us to adjust the contrast of the noise. So I'm going to hold down 1 to bring out a float and plug this into the exponent socket. I'm going to give it a default value of 2. I'm going to start previewing this node and plug this into emissive color. And you can see this is what we get. If we want a higher contrast, we can just increase the value in here. Say if I increase it to 5, this is what I get. And if I decrease it to 1, this is what I get. So I'm going to keep it a default value of 2. And more than that, we can also adjust the edge sharpness if we want. And we can use a cheap contrast node to do that. So I'm going to give it a default value of 0 and plug this. Into a emissive color. So this is what I get. And as I increase the value, say to 1, you can see I have sharper edges. And this might be the result you want. So I'm going to decrease it to 0.1, for example. And we can get a completely different look. So I'm going to keep it a default value of 0. And generally, for noise textures, we want to quickly create different variations. And those parameters, we can quickly have those variations we want. So I'm going to hold down V on my keyboard to bring out a vector 4 parameter. I'm going to call this random seed, and I'm going to put it into its own group. I'm going to name this group to noise settings and give it a default value of 1 for sole priority. So there are 4 channels, meaning we have 4 scalar parameters. And for the red channel and green channel, I'm going to name it to U offset and V offset. So same as our pan distort master, we can use 2 scalar parameters combined with texture coordinate node to adjust the offset of this texture. And by tweaking the values here, we can get the variation we want. All we need to do is combine these 2 values together using MakeFlow 2 and use an add node to add to the texture coordinate and plug this into the append node. I'm going to give U offset and V offset a default value of 0. Later, we can adjust them in the material instance. And for the blue channel, I'm going to call it, we can adjust them in the material instance. And for the blue channel, I'm going to call it random pattern. So this value here can help us to regenerate a random noise pattern quickly. And all we need to do is plug this into the append node. And by changing the third value here for the position socket, we can quickly get what we want. You'll know what I'm talking about when we begin to adjust this value in material instance. All right, I'm going to delete this node, and I'm going to organize this pin. I'm going to drag it there. And for the last value for this random C, I'm going to name it contrast, and I'm going to give this contrast a default value of 2. And plug this into the power node. And I'm going to delete this hard-coded value. And default value of 2, and plug this into the power node. And I'm going to delete this hard-coded value and drag this pin down a little bit. And the last parameter, so this will be the edge sharpness. I'm going to hold down S on my keyboard. I'm going to call this edge sharpness and give it a default value of 0 in here. Plug this into the contrast socket and delete this now and put it into its own group noise settings. Give it a sort priority of 2. And just like that. Now I'm going to click apply and go back to my level. Right mouse button click, create material instance. I'm going to call this mi Perlin base and double click to open it. So now by adjusting all the parameters I just created, I can quickly create different random variations. So if I increase the U offset, this is a totally different noise texture. If I increase the random pattern in here, you can see I'm changing the patterns from my noise texture. And if I want a higher contrast, I can increase the value in here. And we can get a look like this. And if we want to increase its edge sharpness, we can take this value in here, but usually you don't want a value that's too high. So I'm going to try 0.2 first, and you can see this is what I get. I'm going to change it back to 0 and say now we are really happy with this pattern. We want to create textures. We can easily do that thanks to our texture baker. Go back to my level. In my level, I already have the texture baker in here. We can always go to the textures folder and drag out another. But I'm just going to use this one. So I'm going to click it. Press G on my keyboard, select this blueprint. All we need to do is fill in this material to draw and this render target. We can go back to this Perlin noise folder, fill in this material instance, and for this render target, don't forget to change its settings. So I'm going to change it to 512 and 512. Change this render target format to RGB 8 as RGB, and I'm going to fill in this render target. Now by clicking this button, you can see we get ourselves a noise texture. And this is something we can directly use for our VFX. And if we want to have another one, that's really easy to do. By adjusting the values for this material instance, and we can get a totally different look. Now by pressing this button again, we get a different noise texture. And by decreasing the value for contrast and maybe increase the value for random pattern a little bit, and pressing this button, and we get a different noise texture. As simple as that. And these are the values I use for my noise node, and these are the nodes that I use inside of the material. So feel free to take a reference of it if you need. Always come back to this later you ever get stuck in creating the Perlin noise we want. And it's time for a challenge. So your challenge is, I'd like you to noise. Welcome back. How was that? Now I'm going to decrease this contrast to 2, and I'm going to adjust the value for random pattern, change the V offset a little bit, and click this button. And I'm going to quickly do this twice. This twice. Alright, now you can see in my content browser, I already have 6 noise textures, and we got an issue right away. And that's the naming for these different noise textures. Of course, we can name them one by one by selecting it and press F2, and then type in the name we want. But that's just time consuming. Why waste our time on such repetitive tasks when a few lines of code can do this for us? So in the resources dropdown of this lecture, you should be able to find a zip file, download it, and extract it. Inside of it, you can find a U asset, and it's called VFX Naming Helper. So cut this U asset and paste it inside your content browser. I'm going to press Ctrl+V to paste it in here. So this is the blueprint that I created. And what it does is simple. It helps us to rename assets. Now, if you go back to your folder and select all the assets you want to rename, right mouse button click. You can see a new menu entry will be added when you do that. Inside of it, there are 2 functions that I created. So number one is this batch rename. Asset after you select it. A window will pop up, so this can allow us to quickly rename all the assets we selected inside of our content browser. So for the prefix, t underscore is perfect, and for the main name, I'm going to call it Perlin noise. And for the suffix, yes, starts with 1, is perfect. I'm going to click OK. And now you can see all the textures have been renamed correctly. And this just saves time and make our life much easier. And another thing that I want to do, if you recall, we still need to manually disable this alpha channel. Since we are not using alpha channel, it can help us to reduce this resource size. And we can easily do that by selecting all of these assets, right mouse button click, and go to this asset actions. Go down to this bulk and via property matrix. Open it. So this allows us to set all the selected assets property all together. So all we need to do is go to this compression and take this compress without alpha. And now all this text just will be set for us. If I go back to my level, open any one of them, you can see this checkbox will be ticked for us. And right now we can use these noise textures inside this pane distort master. So if I go back to my material instance, I'm going to select this d underscore poly noise underscore 1. I'm going to use it for this distort texture, press this icon. And you can see now the patterns becomes differently. And I'm going to use this one for this dissolve texture. And increase its amount to 1. You can see this is what we get. And if you need, we can always create more noise textures by this current setup we have. One important note here is always amount to 1. You can see this is what we get. And if you need, we can always create more noise textures by this current setup we have. One important note here is it might be very tempting to set up a parameter to control the tiling of this texture. By doing that, we can have larger noise and smaller noise. The issue for that is, if we use parameter to control the tiling directly, we'll no longer have seamless noise. The fastest way to figure out whether or not a noise texture is seamless, we can just adjust its offset value to see if this is actually seamless. So go try it out for yourself. You want to increase another parameter to control its tiling. You'll have to be extremely careful with that value, otherwise the noise texture won't be seamless. And if you still need a larger noise or smaller noise, you can go back to your material, and inside of this noise node, you can tweak the values for the scale here, or you can even duplicate this material and change its name to something like Perlin Big and change this name to Perlin Small. And in that way, you can have different noise textures with different scales. And another thing that I like to mention is that, so if you right mouse button click and go to this scripting as actions, there's another one and it's called fixed MI naming convention. So this is another script that I wrote. What it does is, when we create a material instance from a material, say this m_pen distort master, if we click this create material instance, you can see by default its name will be m_ and has a suffix _inst for it. And the correct naming convention for material instance should start with mi_. So if you right mouse button click and go to this fixed mi naming convention, click it. So what this does is, it automatically removes m_ and _inst for you. All we need to do is change the name in the middle. Again, this is just another tool to help make our lives much easier.
Hey, this is me from the future. So the VFX naming helper that you downloaded from the resources dropdown of this lecture will be an updated version comparing to the one that I use in the course. So the difference with this one is, if you go to your material folder and you create a material instance and right mouse button click to go to fix mi naming convention, a window will pop out, so I added a few lines of code to make this tool more robust. And now, what you can do with this, if you want to change the material instance main name, you can take this, then type in the main name in here. So for example, I'm going to call this material instance test inst, then click OK. And you can see this is my new name with mi added and _inst removed. So this allows you to directly rename your material instance while fixing its naming convention. And if this is not something you just want to fix its naming convention, you can easily do that by creating another material instance. Click this menu entry again, and this time what you need to do is untick this change main name and click OK. And now you can see the naming convention has been fixed. In the next section, we'll need to change the main name of the material instances a lot, so hopefully this tool can help you in saving some time for renaming material instances. Alright, back to the Omi.
And I'm going to start using it, and we need to create more material instance in the future. In this lecture, we created Perlin noise inside Unreal directly, and with the tools and the knowledge we have now, there are more noise patterns we can create, and we'll be doing that in the next lecture. I'll see you in the next lecture. The examples that we made. Welcome! In the last lecture, we successfully created these Perlin noises using the noise node inside of the material graph. And thanks to our texture baker, it's really easy for us to create textures directly from material. Even though now we have these different variations from Perlin noise, they're still the same kind of noise. Is there a way for us to create other types of noise so we can have different distortion and dissolving effect? The answer is yes. We can do just that by tweaking some of the values from the noise node and choosing a different type of noise to start. We can get the variation we want. In this lecture, we're going to start with the Voronoi pattern. So this is the first pattern, the first variation that we can create from Voronoi. You can see we can create acoustics pattern like this. Sometimes this pattern works great for dissolving and even distortion. Let's look at how we can set this up. Go back to my level. I'm going to go back to this noise folder, create another folder. I'm going to call this caustics, and double click to open it. The settings inside that material will be quite similar as the Perlin noise. So I'm going to duplicate this Perlin base, select copy here, and go back to this caustics folder. I'm going to rename this to m_caustic space and double click to open it. So same as our Perlin noise, we'll need these parameters to offer us random variation, and all we need to do is change some of the settings inside of this noise node. So first, I'm going to change this function from gradient to this Voronoi. We're going to start with this, and you can see immediately our pattern changes, and I'm going to increase its quality from 1 to 4, and I'm going to decrease the number of levels, so I'm going to change it from 5 to 1. And you can see, as simple as that. Now we get ourselves this caustic-like pattern. And if you want some larger scales for the noise, you can change the number for the scale here. So if I change it back to 4, change this repeat size to 4 so that we'll have seamless noise, the pattern gets much larger. So I think the value of 8 makes sense in here. And all we need to do now is to adjust its contrast. So right now, the default value for the contrast is 2. Right after I change it to 4, you can see this is what we get. I think I'm going to start with 3 in here, and everything else is the same as the Perlin noise. And there's one more parameter that I like to add. So you can see the brightness of this texture is too high, and we can lower it down by using a divide node. I'm going to create a parameter. I'm going to call this decrease brightness and give it a default value of 2. Put it into this group noise settings, change the sort priority to be 3, and plug this into socket B. Plug this into emissive color. Now you can see this gets much better, and if we keep increasing the value for decreased brightness, say to 3, or maybe 5. This is what we can get. And I'm going to click apply, go back to my level, I'm going to create a material instance. From it, and I'm going to use the function I created, fix its naming convention. So it adds mi automatically for me. Double click to open it. So this is what we get, and we can keep tweaking the values in here. So now I think the brightness is too low. So I'm going to decrease the number here, maybe 4 or 3, and I'm going to increase its contrast to 5 or maybe 4. And we can quickly change the patterns in here, same as our pralinoids. We can offset it. Alright, something like this. And I'm going to bake out this texture. So right mouse button click and select render target. And I'm going to bake out this texture. So right mouse button click and select render target. And I'm name this RT caustic space. And change its settings. So change it to 512, 512. And this render target format, change it to this. And I'm going to find my texture baker, fill in this material, fill in this render target, and click bake texture. And you can see this is the pattern I get. So I'm going to quickly create another one. And I'm going to rename these two textures using the function batch rename, and I'm going to call this caustics. Noise, and click OK. And right mouse button click. Go to this bulk edit properties. And disable their alpha. We can use. So it's quite similar. And by taking some of the values based on what we currently have is this cloud noise. Alright, the second pattern we are going to create is this cloud noise, and by taking some of the values based on what we currently have, this can be easily achieved, and this type of texture works great for distortion. So go back to my level. I'm going to go back to my noise folder. I'm going to create another folder. I'm going to call this cloud noise. And I'm just gonna duplicate this M caustic space and this RT caustic space, copy them to this cloud noise, and in here, I'm going to change their name. For this, I'm going to call it RT underscore cloud base. Double click to open this material. So in order to get a pattern for cloud, we just need to change a few numbers and add one more node. So go to this noise texture. I'm going to keep everything at default. So same as the caustic, I'm only going to increase the numbers for the level in here. So increase it from 1 to 3. And we don't need to decrease its brightness anymore. So I'm going to delete these two nodes. And plug this into emissive color. And you can see this is what we get. And all we need to do is we need to invert this value. And we can use a node 1 minus to do that. So what this node does is it uses the number 1 to subtract the original output. So originally we have a value of 1. Now the output will be 0. And if we have a 0, the output will be 1. And I'm going to plug this into the power socket. And you can see this is what we get. Some cloud noise, as simple as that. And we can see that it will be 1. And I'm going to plug this into the power socket. And you can see this is what we get. Some cloud noise, as simple as that. And we can adjust its value in here. So if the contrast is too high, we can lower it down to 2. Alright, I'm going to click apply and go back to my level, create a material instance. From it and fix its naming convention. Now we can start to adjust its values, and after that we can use texture baker to create the texture we want. And these are my values in my nodes for seconds. Then we're going to end the third pattern that you need. I'm going to pause here for 2 seconds. Cloud noise. So feel free to take a reference of it if you need. I'm going to pause here for 2 seconds. Then we're going to move on. We're going to create today is this marble noise with the ability now to create cloud noise and caustic noise. This is really easy to do. Go back to my level. I'm going to go to my folder. And I'm going to create a new folder. I'm going to call this marble noise, and I'm I'm going to use this caustics as the base. So I'm going to duplicate this material, and I'm also going to duplicate this render target. Move them both to this marble noise and select copy here and change their name to m_marble base and change the name for the render target as well. Double click to open this material. So this is what we have currently. For marble noise, we don't need this decrease brightness, so I'm going to delete these two nodes. And I'm going to go to this noise node. So currently our value for the levels is 1. I'm going to change it to 2, and you can see this is what we get. And in order to get the marble noise, it's actually very similar as our pen distort master. We need to use some noise to distort these patterns. So I'm going to use another noise node to do that. I'm going to right mouse button click and type noise. So this is just another noise node. And first thing, I'm going to plug in a texture coordinate node with a value of 0. So use a pen vector to append a 0 to it. And plug them into this position socket. And right mouse button click to preview this node. So currently this is what we get. I'm going to change this type from this simplex to gradient. So Praline noise, I'm going to change its scale to be number 4 and cancel this turbulence, take this tiling, give it a value of 8 for repeat size as well. And change this output min to 0. And you can see this is what we get. Now, by simply taking the values for levels and the scale here, we can get a very different result. So I'm going to start with 4 in here. Then I'm going to add this noise to the position input of these values. And I'm going to use this noise to distort this pattern. So I'm going to use an add node in here. Plug this into socket B, plug this into socket A. And start previewing it. Now I'm going to plug this into the position socket, and you can see this is what I get. Socket B, this page. So I'm going to start with 4 in here. Then I'm going to add this noise to the position input of these values, and I'm going to use this noise to distort this pattern. So I'm going to use an add node in here. Plug this into socket B, plug this into socket A, and start previewing it. Now I'm going to plug this into the position socket, and you can see this is what I get. This is very similar to curl noise. So if this is something you want, you can go with this. And the theory behind it is the same as our pen distort master. We are using a noise to distort another noise. So right now you can see the distortion is too strong, and we can always decrease it by using a divide node. So right now I'm going to give it a hard-coded value of three and plug this into socket A. And there you go. We have our marble noise in here. And you can use this technique to achieve many different interesting variations. So now if I change the numbers for the levels here, so this number here will determine the details of our noise. If I increase it to 6, you can see we get much more details for all the marble noise. And if I decrease it to 1, and this is what we get. So I think a value of 6 is reasonable in here. So a marble noise like this is perfect for distortion and sometimes even dissolving. So these are the nodes that are used to achieve marble noise, and the only difference between this app and the other noise app is before plugging these values into the position socket, I use another set of nodes to distort this pattern. And these are the values that I use. So the values here are for the main noise in here. The values here R for the distortion noise here. Feel free to take a reference of it if you need. I'm going to pause here for 2 seconds. There's different noises that you just material ribbon, and with the soft, you already have a lot of noise in that. For design our ribbon noise node here, distort to achieve marble noise. Apply this challenge. It takes to that works best. Yeah, you're all go. Welcome back. How was that? And hopefully you agree marble noises using the values of it, and this is what I get and I need. And now we can use this textures for this Niagara system. I'm gonna click this edit static bin. I'm gonna increase its width quite a bit. So instead of 50, I think I'm gonna increase it to 100 so that we can see better. Then I'm gonna go to where it is located. So click browse to asset, open this material instance. Now I'm gonna swap out these noise textures. So for example, for the distortion, we can use our marble noise. So I'm gonna use this one and fill it in here. And you can see this is what we get. And if right now you think the strength decrease amount is too much, we can always decrease it. So maybe to 5. And I think I want it to move faster, something like negative 0.5. Yeah, something like that. And for this dissolve texture, we can use either Perlin or cloud or caustics. I'm going to try this cloud noise for now and increase its value to 1. So you can see this is what we get. Or we can try this caustics in here and fill it in. And you can see this is what we get. We have larger holes on this VFX. I think cloud noise works better. So I'm going to fill in this cloud noise. Yeah, something like that. In this lecture, we created different noise patterns all in inside of Unreal. And these are just a few examples that we made. There are a lot more variations that you can create using the techniques that we've used. So if there's something that you are interested in, feel free, go ahead and do that. And I'll see you in the next lecture. Hey, welcome back. We covered quite a lot of stuff in this section. Now that you already understand all those different stages inside of Niagara and all those different modules, at which stage we should use which modules, and the difference between CPU sprites and GPU sprites. And we also created different types of VFX like this dandelion, this flamethrower, and this simple VFX using Mesh Renderer, created our custom meshes inside of Blender and apply these custom textures on it. And we even bake out that texture ourselves. And these are all the important skills and knowledge you need to have in order for you to create more VFX in the future. Now, before we move on, there's one issue that I like to fix, and that is related to the noise texture. So I'm going to first duplicate this demo display. I'm going to change its name to noise test. So while I was making my marble noise, I made a mistake, and it's no longer seamless. Another way that I use all the time to test whether or not a noise texture is seamless is I simply scroll it. So I'm going to go back to my textures folder. Inside of my noise folder, I'm going to create a material. I'm going to call this m_noise test. And what this material needs to do is simple. I'm going to first change its shading model to unlit and bring out a texture parameter to deep and bring out a panel node and give it a hard-coded value of -0.1 for the X and plug this into the UV socket. And I'm going to swap out this texture with the noise textures we made. So I'm going to first test this Perlin noise. So I'm going to select this T_Perlin noise 2, assign it to this texture parameter, and hit apply. After that, create a material instance from it, fix its naming convention, and drag out our plane, this SM plane face camera, and assign that material instance to it. So I'm going to select it and assign this material instance. And I forgot to plug this RGB into emissive color. So click apply. Now you can see we're slowly scrolling this texture, and this texture is seamless. So this works great. But for my model noise, if I select any one of them and assign it to this texture parameter, you can notice there's this obvious seam in here. And this happens to every one of my marble noise. So if I use this one, you can see I have the same issue in here. And the reason for that is I made a mistake when using the noise node. It comes from this noise node. For the scale here, I give a value of 4, but for the repeat size here, I give a value of 8. So they should have the same value. If you spotted this, great job. Be very careful with these numbers here. Otherwise, you won't be able to have seamless noise. Now, if I click apply, and go back to my level, I'm just going to quickly create another one. So click this texture baker and assign this material instance to it, assign this render target to it, click bake texture. So this is the new one that I created. Let's test out this one. I'm going to open this material instance and go back to my marble noise and assign this new one to it. And now you can see that seam is gone. So be very careful here when you are using the noise node to create noise textures. Make sure those numbers align with each other. All right. Now with all the resources we have and all the skills we have, now with all the resources we make sure those numbers align. And plug this into the program. This RGB, this works great. But sure, one emit noise node. For the scale here, I give a value of 4. But for if you are able to have seamless noise,